There's a black hole out there that breaks every rule we've ever written about how the universe works. It's too big, it's too old, and according to our best physics, it's completely, utterly impossible. Yet it exists. Before you click away thinking this is just another sensationalized space video, I need you to understand something. When I say this black hole shouldn't exist, I'm not exaggerating. I'm not using clickbait language. I mean that Nobel Prize-winning physicists, the world's leading cosmologists, and astronomers using the most powerful telescope ever built, looked at this object and said, quote, "This breaks the laws of physics as we understand them." This is Huddle Videos, and today we're diving into the black hole that's forcing us to rewrite the rulebook on reality itself. The telescope that sees the impossible. Let me take you back to 2023. The James Webb Space Telescope, humanity's $10 billion eye into the cosmos, was scanning a region of space 13.2 billion light-years away. That's not just far, that's looking back in time to when the universe was barely 600 million years old, just 6% of its current age. And there it was, a supermassive black hole containing the mass of several million suns, actively feeding on surrounding matter, blazing across the electromagnetic spectrum with unimaginable fury. The astronomers who found it couldn't believe their data. They checked it, rechecked it, ran the calculations again, brought in colleagues to verify they weren't making some catastrophic error. Because this black hole, designated UHZ1, wasn't just surprising, it was scientifically impossible. The timeline that doesn't add up. Here's the problem, and I need you to really grasp this because it's mind-bending. Imagine you plant an acorn in your backyard, then you go inside for lunch, come back 30 minutes later, and find a massive oak tree towering over your house. Full-grown, ancient-looking, hundreds of years old. That's not just surprising. That violates everything we know about how trees grow. That's exactly what we're dealing with here. This black hole is absolutely massive. We're talking millions of times the mass of our sun, but it existed when the universe was just 600 million years old. To put that in perspective, our current models say it would take several billion years for a black hole to grow this large. Dr. Priyamvada Natarajan from Yale University, one of the lead researchers, put it perfectly. We needed multiple lines of evidence to confirm what we were seeing, because if this is real, it changes everything. And it was real. The growth problem. Let me explain why this black hole shouldn't exist, and I promise I'll make it as clear as possible. Black holes grow by feeding. They consume gas, dust, stars, anything that gets too close. As matter spirals into a black hole, it forms an accretion disk, heats up to millions of degrees, and radiates enormous amounts of energy before crossing the event horizon. But here's the catch, that radiation pushes against incoming matter. It's like trying to eat while simultaneously breathing fire. The radiation creates an outward pressure that limits how fast a black hole can feed. This limit is called the Eddington limit, named after astrophysicist Arthur Eddington. Stay with me here, because this is crucial. The Eddington limit means black holes can only grow so fast. Even if you dumped unlimited food into a black hole, there's a maximum rate at which it can consume matter without blowing away its own fuel supply. Think of it like trying to drink from a fire hose. At some point, the pressure is so intense that more water just sprays everywhere instead of going into your mouth. The math that doesn't work, so let's do the math. If a black hole starts from a stellar mass seed, say 100 times the mass of the Sun, formed from a massive star, and it feeds continuously at the Eddington limit, how long would it take to reach several million solar masses? Several billion years. Minimum. The universe has only been around for 13.8 billion years. This black hole existed when the universe was 600 million years old. That means it had, at most, 600 million years to grow from whatever it started as to the monster we observe. Do you see the problem? It's like asking a baby to run a marathon before they've learned to walk. The timeline doesn't work, the physics doesn't allow it. The math categorically says impossible, and yet there it is. Sitting in JWST's data, undeniable and real. The alternative theories. When confronted with the impossible, scientists do what they do best. They get creative. Maybe, some suggested, this black hole fed at super Eddington rates. Perhaps in the chaotic early universe, black holes could exceed the normal feeding limit, gorging themselves faster than physics typically allows. But even that doesn't work, even if you assume feeding rates 10 times higher than the Eddington limit, which strains credibility. You still can't get a black hole this massive this early. The numbers don't add up, period. So astronomers were forced to consider something more radical, something that challenges our fundamental understanding of how black holes form in the first place. Born big. What if this black hole didn't grow to its current size at all? What if it was born massive? This is where things get truly wild. The discovery of UHZ1 has breathed new life into a controversial theory called direct collapse black holes, or DCBHS. Here's the idea. In the early universe, under very specific conditions, massive clouds of primordial gas, we're talking tens of thousands to hundreds of thousands of solar masses, could collapse directly into black holes without ever forming stars first. No supernova, no stellar evolution, just pure gravitational collapse into a massive black hole from the start. The recipe for the impossible. For a direct collapse black hole to form, you need a perfect storm of conditions. First, you need a massive cloud of pristine hydrogen and helium gas, untainted by heavier elements. In the early universe, before generations of stars had polluted space with metals, this was possible. Picture the early universe. It's dark, cold, just beginning to light up with the first stars. Vast clouds of gas drift through space, pulled together by dark matter's invisible scaffolding. Second, you need intense ultraviolet radiation from nearby galaxies to heat this gas cloud, keeping it from fragmenting into smaller pieces that would form normal stars. The radiation sterilizes the cloud, preventing star formation. Third, you need the gas to cool just enough to collapse, but not so much that it fragments. It's a delicate balance, a cosmic Goldilocks zone. And if everything aligns perfectly, if the conditions are just right, the entire cloud collapses in on itself in a matter of thousands of years, forming a black hole containing tens of thousands of solar masses from day one. Imagine witnessing that moment. No star, no supernova, just a region of space suddenly going dark as a black hole materializes from pure gravitational collapse, warping space-time around it, trapping light in its pull. That's not science fiction. That might be exactly how UHZ1 was born. The evidence mounts. UHZ1 isn't alone anymore. Since its discovery, JWST has found multiple supermassive black holes in the early universe, all far too massive for their age. The pattern is undeniable. Dr. Natarajan's team found that the properties of UHZ1 match the theoretical predictions for direct collapse black holes almost perfectly. Its mass, its location in a dense region of early galaxy formation, the surrounding environment, everything fits. But here's what really sealed the deal: the X-ray signature. When the Chandra X-ray Observatory followed up on UHZ1, it detected powerful X-ray emissions consistent with a black hole of enormous mass actively feeding. The spectral characteristics, the luminosity, the energy distribution, all pointed to a black hole that started big and just kept growing. This wasn't a stellar mass black hole that fed for billions of years. This was a monster from birth. Rewriting cosmic history. The existence of black holes like UHZ1 forces us to completely reimagine the first billion years of cosmic history. We used to think supermassive black holes, the kind that sit in the centers of galaxies, including our own Milky Way, grew slowly over billions of years, patiently feeding and merging with other black holes. Now we know that's wrong, or at least it's not the whole story. Some black holes were born as giants. They entered the universe already massive, already powerful enough to influence entire galaxies forming around them. The chicken and egg problem. This discovery solves one of astronomy's most persistent mysteries, the chicken and egg problem of galaxies and black holes. Nearly every large galaxy we've observed has a supermassive black hole at its center. The mass of that black hole is tightly correlated with the mass of the galaxy's central bulge. They grew up together, influencing each other's evolution. But which came first? Did galaxies form and then grow black holes? Or did black holes form first and help seed galaxy formation? UHZ-1 gives us the answer: the black holes came first. In the early universe, direct collapse black holes formed in the densest regions of dark matter, where gas was abundant. These black holes then acted as gravitational anchors, pulling in surrounding gas and triggering the formation of the first galaxies. The black holes were the seeds. Galaxies grew around them like cosmic oysters, forming pearls around grains of sand. The fate of our galaxy. Here's something that'll blow your mind: the supermassive black hole at the center of the Milky Way, Sagittarius. A star contains about 4 million solar masses. It's possible, perhaps even likely, that Sagittarius A star started as a direct collapse black hole in the early universe, just like UHZ-1. Our entire galaxy, every star, planet, and particle of dust, might owe its existence to a primordial black hole that formed in the cosmic dawn. You, me, everyone you've ever known exists because 13 billion years ago, a cloud of hydrogen collapsed into a black hole that would eventually become the gravitational heart of our galaxy. That's not just science, that's poetry. What else are we wrong about? The discovery of impossible black holes raises an uncomfortable question. What else have we been wrong about? For decades, we've built our cosmological models on certain assumptions. Black holes grow slowly. Galaxy formation takes time. The early universe was relatively simple. Every assumption is now being questioned. JWST is finding impossibly large galaxies, impossibly bright quasars, impossibly massive black holes, all in the universe's first billion years. The early universe wasn't simple. It was violent, rapid, and stranger than we ever imagined. More monsters in the dark. UHZ-1 was just the beginning. Since its discovery, astronomers have been hunting for more direct collapse black holes, more impossible objects that challenge our understanding, and they're finding them. JWST has identified dozens of supermassive black holes in the early universe, many even more massive than UHZ-1. Each one is a puzzle piece, helping us reconstruct the wild story of cosmic dawn. Some of these black holes are so bright, so energetic, that they're outshining entire galaxies. They're called quasars, and they're among the most powerful objects in the universe. The fact that quasars existed when the universe was less than 1 billion years old tells us that direct collapse wasn't rare. It might have been common, perhaps even the dominant pathway for forming the supermassive black holes we see today. The technology that made it possible. None of this would have been possible without JWST. Its infrared sensitivity allows it to peer through cosmic dust and detect light that's been traveling for over 13 billion years, stretched into the infrared by the expansion of the universe. Think about that. We built a telescope so powerful that it can see objects that formed when the universe was in its infancy. We can watch black holes feeding in the cosmic dawn, galaxies assembling for the first time, the universe waking up. And what we're seeing is stranger and more wonderful than anyone predicted. What comes next? The search for direct collapse black holes is just beginning. Astronomers are developing new techniques to identify these objects, looking for specific signatures in their light that distinguish them from black holes that grew through conventional feeding. Future observations will map out how common these objects were, how they influenced early galaxy formation, and whether they're truly the seeds of all supermassive black holes. And here's the exciting part. We're living through the discovery. This isn't ancient history or settled science. This is happening right now, in real time, as astronomers analyze JWST data and publish new findings. The impossible black hole that started this journey, it's leading us toward a complete revolution in how we understand cosmic history. So let's come back to where we started. There's a black hole out there that should not exist. It's too massive, too old, formed too early. But it does exist, and its existence is teaching us that the universe doesn't play by the rules we thought we'd figured out. UHZ-1 and black holes like it are showing us that the cosmos is stranger, more violent, and more creative than our theories predicted. They're revealing that in the universe's first moments, gravity could work miracles, collapsing clouds of gas into massive black holes that would become the gravitational hearts of galaxies. They're proving that the impossible is just the not yet understood. And most beautifully, they're reminding us that every time we look deeper into space, every time we build a better telescope, every time we dare to question what we think we know, the universe rewards us with wonders that exceed our wildest imagination. The black hole that should not exist is real. It's out there right now, 13.2 billion light-years away, still feeding, still growing, still defying our expectations. And it's just one of countless mysteries waiting to be discovered. If this story amazed you, like it amazed me, smash that like button and subscribe for more cosmic revelations. Drop a comment. Do you think most supermassive black holes formed through direct collapse, or are objects like UHZ one rare exceptions? And remember, the next time someone tells you something is impossible, tell them about the black hole that broke the rules and exists anyway. Until next time, keep questioning everything.